Hello everyone, I'm Anisha. Welcome all of you to my channel, that is virtual classes. So today in this class we are going to continue your chapter number 4 that we have started, that is the world of metals and non-metals. Okay, so this will be your part 2. If you haven't watched the first part, kindly watch that first. The link is given in the description box. And yes, don't forget to like, share and subscribe my channel. Okay, and yes, if you want to listen in Hindi explanation, you can again find the link in the description box. So today the explanation will be in English only. Okay, so in our previous class, what we have learned? We have learned that metals are generally hard, isn't it? They are lustrous, that means they are shine, there is a shine, and they are malleable, that means where you can convert them into a sheet, or sheet also, like for example the aluminum sheet, aluminum foil, isn't it? And they are ductile, that means you can convert them into a long wire, and gold and silver are the most ductile metal, and also they are good conductors of heat and electricity. So today in this class we are going to see effect of air and water on metals. First we are going to see about iron. Okay, so you would have noticed that iron objects develop brown deposits when left in open for a few days. Have you noticed or not? See, there used to be a brown deposit. What we call them? We call them as a rust, isn't it? That is the rusting. So about that we are going to learn here. Okay, and we are going to see whether in the presence of air only there used to be brown deposit, or whether there in the presence of water only the brown deposits form, or it is on the presence of both air and water. Okay, so in which condition would an iron object develop brown deposits? Like there are three conditions given here. The first one is when it comes into contact with a dry air only, or when it comes into contact with water only, or when it comes into contact with both air and water. So we are going to find out on these three statement given here on which point, okay, on which point the brown deposit is formed. Okay, that is whether in air only, or whether in water only, or in the presence of both air and water. So for that, what we are going to do, we are going to conduct an experiment. Okay, so now let us get ready for an experiment here. So this is going to be very interesting. And if you have any doubt, you can ask me in the comment section. So there is a question here: be careful while handling the iron nails. So for this experiment, what do you need? You need a shining iron nails. Okay, if you don't have a shining iron nails, and if you are using an old iron nails, make sure to remove the brown deposit, because there used to be brown deposit kind of reddish and brownish color. Yes or no? I hope you have also observed that. So, and how we are going to remove that? By scrubbing them with the help of small piece of sandpaper. Okay, and we need 3 dry glass bottles or test tubes. Okay, so we need nails, iron nails, if possible new one, which is still shining, isn't it? That is the color is like slightly silver color, and we need some tight fitting caps or stoppers. Okay, so here the first experiment here, A, B and C. Okay, we need 3 glass bottles, okay, and some iron nails. So now let us conduct our experiment. So take 3 iron nails and tie each iron nails with a thread. Okay, we need a thread as well. Okay, so like this is as shown in this diagram. Okay, you have to take 3 iron nails and tie each of them with a thread, and after that place 1 iron nail and some silica gel in the glass bottle A, that is here, and tightens the cap or stopper. That is, the silica makes the air dry. Why we are putting this silica gel? In order to make the air dry. And I hope you know what is the silica gel. It is usually found found in a small pouch, isn't it, like in medicine bottles or water bottles or shoe boxes. Okay, so that to make them dry, to keep them dry. So what do we need to put in this first jar? That is the iron nail which is been tied with a thread, and some silica gel, that is no water, isn't it? That is only air is there. Okay, only presence of air is there. And in the second one, now in this B, okay, place 1 iron nail in glass bottle B, pour freshly boiled and cooled water. That means you need hot water as well as cool water. Okay, why? To remove the dissolved gases if present any, and into it until the iron nail is completely dipped in it. Here, see, the water is still here, isn't it? So the iron nail should be completely immersed in it. Okay, that means completely dipped inside the water. And now pour some oil to form a layer over the surface of the water. The layer of oil on the surface of the water prevents the air from dissolving in the water. So again you need to pour some oil also here, so that you are preventing the air from dissolving in the water. Okay, so cap the glass bottle tightly. Now you need to cap this glass bottle tightly, and in the first one also you need to again cap this glass bottle tightly. Okay, now in the C, okay, place one iron nail in the glass bottle C and pour some water so that the iron nail is partially dipped, means half. Here, see, half part is inside the water and half part is in the exposure of air. Okay, so keeping this glass bottle unstoppered means you should not cap, okay, you should not tie the bottle with a cap. That means you have to keep it open. Okay, so this allows the iron nail to come into contact with both water and air as shown in figure 4.4c. So this will allows this iron nail, okay, to come into contact with both water is present here, and air is present here. I hope this is clear. So now what we are going to do next, place all the glass bottles undisturbed at room temperature and observe the change for around 8 to 10 days. So after 8 to 10 days you need to see the change. Okay, you need to see the observe whether brown deposit has been formed, and in which of the glass jar a brown deposit has been formed, either it is in the A, B, whether it is in the A or B or C. Okay, so now let us assume that we have already observed it, and let us write a result in our table. Okay, and the explanation is also given there, don't worry. So formation of brown deposit on iron nails. So here, what were the condition? There were 3 jars, A, B and C, isn't it? So first, presence of water. In A there was no presence of water, that is why no is written here. And here presence of air, yes, presence of air was there. And what will be your observation? No brown deposit is formed. That means only along in the presence of air you will not see any brown deposit, means there will be no rusting in the iron nail. Okay, and in the second condition, that is in the B, there was a water, yes, there was water. Presence of air, no, there was no presence of air, because we have pour on some oil also, isn't it, in order to prevent the air to enter into the water, yes or no? So there again in this case no brown deposit is formed. So when that means only in the presence of water also you will not find any rusting on the iron nail. And now see, in C what we have done, there was presence of water, yes, and there was presence of air, yes, isn't it? So here in this case we will observe that brown deposit was being formed. That means in the presence of both water and air only the process of rusting takes place. Okay, further explanation we will see here, it is given. Okay, so what can you conclude from these experiment? It is observed in a glass bottle A and B that iron nails do not show any brown deposit. So this is our observation, yes or no? So what does this observation indicate? So what does it indicate? It indicates that brown deposits or discoloration on the iron nails do not develop when the iron nail is kept in dry air alone, that is in bottle A that we have done, or water alone, that is in bottle B. This is our observation. So this is important. Okay, so it indicates that brown deposits or discoloration on the iron nail do not develop when the iron nail is kept in dry air alone as well as on water alone. I hope this was clear. However, in a glass bottle C, there was presence of water as well as presence of air, yes or no? So the iron nail shows the presence of brown deposits. These indicate, what does this indicate? These indicates that the presence of both water and air is essential for these deposits to develop. That means the presence of both water and air is essential in order to form that rusting. Okay, otherwise only if it is kept in air there will be no rusting, and only if it is kept in water there will be no rusting. Okay, so thus moist air, see, moist air, okay, is responsible. That means in the air there is a presence of water is also there. Okay, that is water vapor in the form of vapor. Okay, moist air is responsible for development of brown deposit on objects made of iron. I hope this is clear. So this brown deposit is called what? Rust. This is what I was telling you. Okay, so this brown deposit is known as what? It is called rust. And the process of formation of rust on objects made of iron is called what? Rusting. That means the process of formation of this rust on the objects which are been made up of iron. Okay, made up of this iron, they are called what? They are called rusting. So I hope this is clear, and the experiment is also clear. What do we conclude? We conclude that rusting occurs only in the presence of both air and water, that is in the moist air. Okay, so now let's continue. Many other metals also exhibit discoloration when kept open in the atmosphere. So many other metals, so now we were talking about iron, isn't it? So just like iron, many other metals also, they brown deposit is being formed, or there is a discoloration when kept in open in the atmosphere. Okay, have you noticed the formation of green coating on the surface of copper objects or black coating on the surface of silver objects? Have you noticed, especially in the copper objects which are being used in your mandir, isn't it, like their lota and all, you will see that if you don't clean it from time to time, it turns into somewhat greenish and reddish color, yes or no? So that means it has been deteriorating. Okay, and you will see black coating, okay, black coating on silver object, especially silver object, it is not been cleaned for a long duration of time. Especially say if your mother is wearing any silver jewelry, okay, for a long time, that means of a daily use, you observe that you will find some black coating over there. Okay, so that this is the gradual deterioration of metal surface, okay, caused by air, water or other substance, is known as what? Corrosion. I hope this is clear. So gradual deteriorations of the metal surface, okay, metal surface which has been caused by air, water and other substances, what do we call? We call it as a corrosion. So is corrosion clear? So do you know that rusting of iron is a serious problem in our country? So why? Because every year an enormous amount of money, means huge amount of money, is being spent to replace or repair iron structure damage due to rusting. So we need a lot of money, okay, in order to repair or replace some iron structure which has been damaged due to rusting. And how can you prevent rusting? We can prevent rusting by, see, there are several methods, okay, such as painting, oiling, greasing and applying protective layer of zinc metal on iron, that is what we call as galvanization. Okay, and about this you will learn more in your higher grade. See, suppose for example in your home, in your window, okay, the grillings, what are the grillings made up of? The grillings are maybe made up of the iron, isn't it? And we usually paint that grilling. Why? So that we can prevent them from rusting. Otherwise if we don't apply paint from time to time, then what will happen? That will be damaged. Okay, so the process of applying that paint over that iron grill is known as what? Galvanization. I hope this is clear. So now let us see a fascinating fact here. The wonder of ancient Indian metallurgy. Metallurgy means the work related with metal, okay, innovative work related with metal. So here the iron pillar of Delhi was made in the time of Chandragupta II. So this iron pillar which you can see here in this image, okay, this was being built during the time of whose reign? Chandragupta II. Okay, more than 1600 years old. So it is about 8 meter high and weight more than 6000 kilograms. So what is interesting about this iron pillar is that despite all these years facing wind, rainfall and intense weather, it has barely any rust. That means this tells us that the skill that were being developed during that time in the metal technology, yes or no? So they have made this iron pillar in such a way so that it prevents rusting. That means they have galvanized them properly, yes or no? So in other words, it has been made in a way that resists rusting. So this tells us about the skill that were being developed in metal technology in India, as I have told you earlier. So this was, I think this was clear. So next let us see about other metals. Okay, so that was about iron and other metals. So what do we learn? What have you learned until now? You have learned about the rust, the process of rusting, corrosion and galvanization, yes or no? So now effect of air and water on other metals. So now we will see effect of this air and water on other metals. Okay, so again, in order to understand this, we need to do one experiment. So the teacher may demonstrate this activity. Caution, and again there is a caution. Why? Because it is advisable to student to wear protective eyeglasses and keep safe distance. So here, in order to do this experiment, what do you need? You'll need some magnesium ribbon that is about 3 to 4 centimeter long, and you have to clean it with a piece of sandpaper and hold it with a pair of tongs, that is this one, okay, tongs, that is what we call chimta, isn't it? Ignite the other end using a spirit lamp or a candle. So this is the spirit lamp here, or if you don't have spirit lamp, you can ignite it with candle also, okay. And also you need a watch glass here, Why? Because this magnesium ribbon, after burning, it will turn into white powder. Okay, so in order to collect that, you need this watch glass. So let the magnesium ribbon burn. What do you observe now? You'll observe that the magnesium ribbon burns with dazzling white flame and changing into a white powder. So you'll observe that, see, here you can see the flame. Usually the flames is of yellow color, like you can see here in this spirit lamp, it is yellow color. But here magnesium river, it is purely white. Isn't it? Dazzling white flame is there. So this is what we will observe. Okay, and after burning of this ribbon will turn into a white powder. Okay, so we are going to collect it on a watch glass, and this powder is magnesium oxide. So what is this powder now? The ribbon has become now magnesium oxide. Okay, so it is formed due to the reaction between magnesium and oxygen present in air. So how this is formed? This is formed due to the reaction. Okay, due to the what? Reaction between magnesium and oxygen present in the air. So in air, oxygen is present, yes or no? So when magnesium ribbon is reacting with the oxygen, it forms oxide, that is magnesium oxide. Okay. Now after that, what we need to do? We need to add some few drops of warm water to the white powder, stir it well and check its nature. So remember how we can check its nature? We have, like, you can recall your chapter that is exploring substances acid, basic and neutral. Like we used to check whether the material or the substance is acid, is acidic, basic or neutral by using what? Litmus paper, isn't it? So now we are going to check that one, okay, using acid base indicator, that is the litmus paper here. So what you can see here, so this is the white powder, isn't it? This is the watch glass and this is the white powder here. You see these blue litmus paper doesn't turn color and red litmus paper turns into blue. What does that indicate? It indicates that it is basic in nature, that is the magnesium oxide is basic in nature. Okay, so what effect does the solution have on blue and red litmus paper? You would observe that it changes the color of red litmus paper to blue, hence it is basic in nature. Okay, that means this metal magnesium oxide is what? It is basic in nature. So generally, this is important here. Okay, generally oxides of metals are basic in nature. Means oxide of all metals are what? Basic in nature, and oxides of non-metals are acidic in nature. Okay, this is what you are going to learn here. So remember, okay, oxide of metals will be what? Basic in nature. Okay, oxide of metal, let me just write OM, okay, of metal will be what? Basic in nature, and oxide of non-metal will be acidic in nature. Okay, one will be basic and another will be acidic. So remember this point. Okay, so we will discuss this burning of magnesium ribbon further in the chapter changes around us, physical and chemical. So we are going to discuss further in your upcoming chapter, that is changes around us, that is physical and chemical. Okay, about the burning of this magnesium ribbon. So here what you need to understand? You need to understand that the magnesium ribbon, okay, that is it is a metal. So when burned, when it react with oxygen, what happened? It turns into magnesium oxide, and that magnesium oxide, the nature of that magnesium oxide is what? It is basic in nature. Okay, I hope this was clear. So again, another information has been given here. So do you know sodium is a metal? We know that sodium is a metal, isn't it? Which is stored in kerosene. Why it is stored in kerosene? Because it reacts vigorously with oxygen and water, and when a lot of heat is generated in the reaction. So when this reaction happens, if sodium is being stored in open air, then what will happen? There will be a reaction and which produce a lot of heat. Okay, a lot of heat is being generated. So that is why storing sodium in kerosene prevents its exposure to moisture and air. Can you predict the nature of its oxide? So what will be the nature of this oxide? Just now what we have learned, that oxide of all metals is basic in nature. So here oxide of sodium will be what? It will be basic in nature. Okay, so let us now discuss some substances that do not behave like metal. So now further we are going to do one more experiment. There we will learn that there are some metals, okay, which doesn't behave like metals, okay, in air and water. I hope this is clear. So now let us see, let us experiment demonstration activity. So the teacher may demonstrate this activity. So here again there is a question, why? Because when we are going to burn this sulfur powder, okay, a poisonous gas, not poisonous, some gas has been produced, okay, which can be harmful if inhaled. So this is the question here. So in order to do this experiment, what do we need? We need a long spoon. What is this long spoon called? Deflagrating spoon. Okay, and if you don't have this deflagrating spoon, then what you can do? You can use a metal wire here, and you can use a metallic cap of a bottle or anything. Okay, it should be metallic. Okay, and you can use that, okay, in order to do this experiment. So this is what it has been written here, all right, because we are going to burn this one. So now what we are going to do? See, heat it on flame. We are going to heat this sulfur powder which is here, okay, inside this cap or in this spoon, okay. And as soon as the sulfur starts burning, introduce the deflagrating spoon into a glass jar or a glass tumbler. So as soon as this sulfur starts burning, what you need to do? You need to put inside a glass tumbler, okay, and you need to with a lid to ensure that the gas produced do not escape, okay, and you should cover it with a lid so that the gas which has been produced after with the burning of the sulfur doesn't escape, okay. And remove the lid after 3 to 4 minutes and take out the deflagrating spoon. So after 3 to 4 minutes you remove the cap, okay, you remove the lid or the cap, whatever you will be doing it, and take out the spoon, that is the long spoon, that is what we call deflagrating spoon, okay. And you need to add some small quantity of water into the glass jar here, inside this glass jar, and add some small quantity of water and quickly place the lid back and shake it so that the gas dissolve, okay. So now you need to place some pour some water there, okay, and you need to shake it, okay, and quickly you need to again cover it back and again recall the chapter again. That means the exploring substance, acid, basic and neutral, means you are also again going to indicate the nature, okay, using an acid base indicator, that is using a litmus paper, okay, and check whether the solution obtained after the adding of water to the gas jar is acidic or basic. So we are going to see the why we have added water, so that we can check its nature, okay, nature of this gas which is present inside this glass tumbler. So what we will observe? See, as this is non-metal, isn't it? It will turn blue litmus paper into red, red litmus paper into red only. That is, it is acidic in nature. Okay, you would observe that it is acidic in nature. So, on burning sulfur in air, that is in the presence of oxygen, sulfur dioxide gas is formed. Okay, the gas which was formed inside is known as what? Sulfur dioxide. Okay, and on dissolving sulfur dioxide gas in water, sulfurous acid is formed. Sulfurous acid is formed. So the gas which was inside the gas which was inside the glass jar, it is known as what? Sulfur dioxide. Okay, and and after we have added water in that gas, when we add the water in the sulfur dioxide, what it becomes? It becomes sulfurous acid. Is it clear? Sulfurous acid. Okay, you need to remember this. So does sulfur behave in water the same way metals do? No, it doesn't behave, isn't it? Metal oxide, what the nature of the metal oxide was what? It was basic. But here the nature of sulfur dioxide is what? It is acidic in nature. That is written here, isn't it? Acidic in nature. So this is the difference here. Okay, again here. Let us again explore. Okay, does sulfur behave in water the same way metal do? I have given the answer, it is no. So let us again examine. Okay, take some sulfur powder in a glass tumbler. Now again take some sulfur powder in a glass tumbler. Add small amount of water to it. Okay, again you add some small amount. This time instead of burning or heating, we need to add some water into it. Okay, what do you observe? You may have noticed that there is no reaction when sulfur is placed in water. That means it behaves differently, isn't it, with air and water than metal. And when if otherwise what happened in metal, in the case of iron, what we have seen, rusting was there, but here you will not see anything, okay, any such reaction. So again, next, phosphorus. Phosphorus is stored in water. Why again phosphorus is stored in water? As it catches fire and when exposed to atmospheric air. Okay, these substances are usually soft and dull in nature. This phosphorus, sulfur, okay, these substances are what? These are soft and dull in nature. And why phosphorus is been stored in water? In order to prevent catching of fire. Okay, because if you are keeping phosphorus in the open air, what will happen? It will catch fire. So that is why it has been stored in water. Okay, so they are neither malleable nor ductile. Okay, they means here sulfur as well as phosphorus. Okay, they are neither malleable nor ductile. So what these are the properties of metal, isn't it? But here they are neither malleable nor ductile. That means they are not sonorous as well. That means there is no ringing sound here. Okay, and they are also poor conductor of heat and electricity. So these are called non-metals. So what we call this? These are called non-metals, and their oxides are acidic in nature. Said this is what I have told you earlier also. The oxides of metal are always basic, and the oxide of non-metals are always what? Acidic in nature. Okay, I hope this was clear now. Here, some other metals are some other non-metals. Okay, non-metals are what? Oxygen, hydrogen, nitrogen, carbon, etc. And these must not be confused with materials such as plastic, glass, wood, rubber and paper. See why these plastic, glass, wood, rubber and paper has been mentioned here? Because earlier in our experiment before, we are like in where we have done about whether the bulb glows or not, we have used these products here, isn't it? This material, that is the plastic, glass or wood, and we have called them as non-metal. So these should not be confused with these plastic, glass or wood, rubber and paper. Okay, because these materials are not classified as metals or non-metals because they are not element. But here oxygen, hydrogen, nitrogen, carbon, etc., these are all non-metals. Why? Because they are elements. So here let us see some small information about elements also, about which you are going to learn in more detail in your higher classes, but here only a glimpse is there. Okay, so dive deeper. Metals and non-metals are subcategories of substance called element. Okay, and an element is a substance that cannot be broken down into simpler substance. So an element is a substance which can be broken down further into more simpler substance. All right, and presently there are 118 elements are known, and these elements are the basic building block of all matters. Okay, and some are naturally occurring while others are artificially made in the laboratory and do not exist in nature. You will study more about elements in your higher grade. So for here what you need to understand, that metals and non-metals both are what? Are subcategories of element, and elements is usually a substance which cannot be further broken down into more simpler substance. That means they are already in their most simpler form. Okay, simplest way. And there are presently 118 elements, okay, which are being known to us, and some of which are being naturally produced and some are being artificially made in the laboratory, okay, and which do not exist in nature. So about them you are going to learn more in your higher classes. So now we have learned about the experiment of metals and non-metals, isn't it? So are non-metals essential in everyday life? We are going to see whether these non-metals are essential in everyday life or not. See, just now what we have learned? We have learned that oxygen is also a non-metal. So yes, obviously they are essential, isn't it? So you often observe many metals in your day-to-day life because of their distinct properties such as their lustrous nature, heat and electrical conductivity and high strength. So this is what we have observed, isn't it? Like we have learned about metals that they are very much useful, they are lustrous, isn't it? They are hard, they are being used in making our day-to-day tools, so many tools, they are very much helpful, and they also conduct electrical conductivity, they are being used in electrical fittings, and they have a very high strength. So however, this should not give an impression in your mind that non-metals are not important in our life. So they should not create any impression that non-metals are not important, because non-metals are important, because without non-metal, that is the most important one, the oxygen, we will not be able to live also, isn't it? So this is what we have given here. So we breathe in oxygen, which is a non-metal, and without it we would not be able to survive. Can you think of any other uses of oxygen? Can you think any other uses of oxygen apart from breathing in and out? So it is been needed by the plants also, isn't it? So here the first non-metal is oxygen, and it is very much useful because without it will not be able to survive. And second is carbon, third here is nitrogen, fourth here is chlorine, and another is a solution of iodine. Okay, so we are going to see about them. So carbon is essential in everyday life because it is the building block of all life forms. Why? Because it is a key component of protein, fats and carbohydrates, which are necessary for growth and energy, and they are being necessary for the growth of our body also, isn't it? If you don't intake protein, fats and carbohydrates, what will happen? You will not be able to grow properly, you'll become very lean and thin, or otherwise you will die also, isn't it? So carbon, again here it is very much essential. It is why? Because it is the building block of all life forms. Okay. And next, nitrogen, it is used in the manufacturing of fertilizers and other chemicals. Means in use of fertilizers, it means which has been used in order to produce food in agriculture sector. Otherwise what will happen? If there were no fertilizers, then the food product grows will not be, there will be no improvement, okay, in plants, growth of plants. So it is essential nutrient for the growth of plants. And next is chlorine, is a non-metal commonly used in water purification. In order to purify water, what do you need? What you can add there? You can add chlorine and your water will be purified. And next we have a solution of iodine, that means it is also a non-metal and it is usually applied on wounds as an antiseptic. So these are all very much necessary. That means both metals as well as non-metals are very much important in our life. Okay. So we are almost coming towards the end of our chapter. So now let us see one more thing here, science and society. Do you know that many metals and their alloys, that means mixture of two or more metals or a metal and a non-metal, means when you are mixing two or more metals, and if you are mixing metal with a non-metal, that means earlier also we have seen an example, like when we are mixing iron and carbon. Carbon is non-metal and iron is metal. Steel is been produced there, isn't it, which is been used in the suspension bridge. Remember that one? So that is what we call alloy. Okay, when we are mixing two or more metals or metal and a non-metal, are important for daily uses and utensil and tools. Means you can use, so see we have two utensils of steel also, isn't it? That means it has been made by mixing metals and non-metal. Okay, and they are also important for modern technologies and essential in almost every industries. Okay, and these are important in not only in our life, it has been important in modern technologies, and it has been essential in every industry. Like some special metals are there, okay, are also used in atomic energy, like such as zirconium. This is also a metal. Okay, or in aerospace, that is the titanium. All right, so these are special metals which are being used in atomic energy or the aerospace. Okay, so metals are very much important. And in India, many metals, especially irons and aluminium, are recycled to minimize waste and contribute to sustainability. Means in India, so many metals are being recycled, means we reuse them. Okay, metals like iron and especially aluminium, so that we can minimize their wastage, because these are naturally occurring metals, isn't it? And if we are going to use all the metals, what will our future generation will use? So we are contributing towards the sustainability, so that we are keeping something for the future generation as well. Okay, so this was about the science and society. Some extra knowledge was there, and we have completed our chapter. If you have any doubt, you can ask me. Okay, and as you know, we will be doing this summary in a very detail, but you can read these points. You will find some differences between metals and non-metals. Like metals and non-metals are differentiated based on their properties. That is, generally metals are lustrous, whereas non-metals are non-lustrous, and metals are generally malleable and ductile, while non-metals do not have these properties. We have learned, isn't it? And metals are good conductor of heat and electricity, but non-metals are poor conductor of heat and electricity. And metal reacts with oxygen to produce metal oxide, which are basic in nature. Again, non-metal react with oxygen to produce oxide, which are acidic in nature. So this is what we have just learned. So we are going to do the summary in detail, so don't worry. And we are also going to do your question and answers, textual question and answers, everything. So with this, we have completed this chapter. If you have any doubt, you can ask me in the comment section. And yes, don't forget to like, share and subscribe my channel. All of you have a very nice day ahead. Bye.